Okay, we're going to discuss ionic bonding. In the last video, we discussed metallic bonding, and that is the bond between a metal and a nonmetal, and that is a really, really strong bond. It is kind of boring, doesn't do much because it's such a strong bond. Next, we have ionic bonding. Ionic bonding has the word ion in it, so right there should give you an indication that it is going to have something with a charged, it's going to have a part that is charged. Okay, we're dealing with ions here. This is the bond that is formed between metals and nonmetals. And how's that bond formed? It is formed by the transfer of electrons. The metal likes to become a cation. It likes to give away its electrons. So it transfers its electrons to the nonmetal who wants those electrons. It completely gives them away. Okay, so the compound that is formed from the attraction between the cation and the anion is called an ionic compound. So when your metal gives away its electrons to the nonmetal, the metal becomes positive, and your nonmetal is negative. Positive and negative are attracted to each other, so that makes them stick together, and that's what holds them together. That charge, that electrostatic charge between the cation and the anion. Okay, so let's talk about some characteristics first of all. Example of ionic bonding is sodium chloride. This is a metal plus a nonmetal that are bonded together with an electrostatic charge. That's table salt, sodium chloride. Okay, it's an ionic compound. They're formed from a cation. Sodium likes to become a cation, and an anion. Chlorine likes to become an anion. A metal and a nonmetal. Things from one side of the periodic table to the other side of the periodic table. Your ionic compounds overall have a neutral charge. There's a positive part and a negative part within it, but overall it is a neutral charge, and I will show that to you in a little bit. They are good conductors of electricity in the liquid and aqueous state. So let's go back to the metallic bonds. Metallic bonds, we said that they were good conductors in all states. Okay, that means as a solid, liquid, and gas. This one is only a good conductor in the liquid state and in the aqueous state. Okay, so what does it mean to be in the liquid and the aqueous state? So liquid means just what it sounds like. You have a metal, if you can melt it, if you have an ionic compound, if you can melt it, then it's a liquid. Okay, pretty simple, kind of like ice becoming water. If you have a metal, and you melt it, that's liquid. So if you have an ionic compound and you get it to melt into its liquid state, then it will conduct electricity. There's also something called your aqueous state, and that's where you put your ionic compound in water, and it dissolves in water. If you go back and think about your unit on mixtures, we said that if you dissolve something in water, you can get that original compound back by evaporating the water. It's not a chemical reaction. It's just dissolving. Okay, but if you put something like sodium chloride, table salt, in water and dissolve it, and then you try to run a current through it, then you can, but it won't happen in the solid phase. So when you're looking at electrolytes in your Gatorade that you're supposed to drink when you're dehydrated, all it is ionic compounds that have been dissolved in water. So now they can conduct and they allow passage through your cell membranes. Okay? Just like your metallic bonds, they also melt at high temperatures. They want to be solids. They melt at high temperatures, and it's a very strong bond, but it's not as strong as metallic bonds. And your ionic compounds tend to be solid crystals at room temperature, like table salt. Okay? So your ionic bond is formed by the electrical attraction between cations and anions, between something positive and something negative. Your cation forms, you have something positive and you have something negative, and that makes them stick together. It's always between a metal and a nonmetal, or more specifically, between a cation and an anion, because it can be between polyatomics that have charges as well. And in pure ionic bonding, which is what we talk about in this class, your atoms are completely giving up their electrons or transferring them to other atoms. Examples of of ionic bonding. Sodium chloride, we just talked about, that's table salt. Calcium chloride, this is what they use up in the north when they ice the roads. They're putting calcium chloride on the roads. This is potassium oxide. If you notice, all of these are metal plus nonmetal, metal plus nonmetal, metal plus nonmetal. This becomes a cation, this becomes an anion. Cation, anion, cation, anion. Okay, so let's look at what that looks like. Okay, so if you were to show a transfer of electrons, the first thing you have to do is identify your metal and your nonmetal. In this case, sodium is your metal, fluorine is your nonmetal. You're always going to write the metal first. So you're going to write down the symbol for sodium. Then you're going to look on your periodic table and you're going to say, how many valence electrons does sodium have? Oh, sodium has 1 valence electron. So you show that in an electron dot structure. Okay, then we have fluorine. We put fluorine down. How many valence electrons does it have? It has 7. So if you notice, there's like a little space right there, a little hole right there where an electron can go. So sodium comes along and says, I've got an electron. Anybody want an electron? And fluorine's like, I'll take your electron. So sodium throws that electron at fluorine. Okay, so you end up with a formula that you had 1 sodium and 1 fluorine. And what it actually looks like is this. You have an Na that has a positive charge because it lost its electron. It lost something negative. We have more protons than electrons now, so it is positive. And now you also have a fluorine. Now fluorine originally had 7 electrons, but sodium gave it 1 of its electrons. So now it has 8, but since it gained 1 electron, it has a negative charge. We have a +1 here, we have a -1 here. Overall, it is neutral. This is the chemical formula you write from this process. Sodium fluoride. Just like in life, we lead with the positive in chemistry. The positive thing goes first. Sodium is the positive thing. Fluorine goes second. Let's try another one. Okay, let's do another one. Let's do lithium and bromine. Lithium is Li. Bromine is Br. Lithium, if you look on your periodic table, has 1 valence electron. Bromine, if you look on your periodic table, has 7 valence electrons. I'm not going to pair up until I have to. 1, 2, 3, 4. Now I can pair up. 5, 6, 7. Okay, so we have a lithium and we have a bromine. So what happens is that your lithium starts saying, I've got an electron. Anybody want an electron? And bromine's got a little space right there. You're like, I'll take your electron. So lithium grabs its electron and throws it at bromine into that space. And what happens when you do that is lithium just lost its one valence electron. So it has a +1 charge because it lost 1 electron. Bromine originally had 7 electrons. Originally had 7 electrons, but now it got 1 from lithium. So now it has 8 electrons total. It's got 1 extra, so that's a minus charge. This side's a +1, this side's a -1. Overall, your molecule is negative. +1, -1. Overall your molecule is neutral. So if you were to write the formula for this, we had 1 lithium, write our positive first, and we have 1 bromine. Lithium bromide. Okay, let's try another one. Let's try magnesium and chlorine. So here you have to identify your metal and your nonmetal. Magnesium is your metal, chlorine is your nonmetal. So we write our metal first because we want the cation to go first, and then we're going to write our nonmetal second. First of all, we look, magnesium has how many valence electrons? 1, 2. Chlorine has how many valence electrons? 7. Okay, so now magnesium wants to get rid of these 2 electrons. And chlorine has room for one electron. So magnesium starts saying, I've got electrons. Anybody want an electron? I've got an electron. And magnesium says, the chlorine says, I'll take it. So magnesium throws one of its electrons at chlorine. That chlorine has 8, so chlorine is happy. But magnesium still has one extra electron. So it starts bartering, saying, I've got an electron. Anybody want an electron? And chlorine calls its chlorine friends and says, hey, magnesium's giving away electrons. Would you like one? And so that's what happens. Another chlorine shows up, and magnesium can throw its electrons at it. Okay? So when you put this together, you have one magnesium molecule and 2 chlorine molecules. You get an MgCl2. That is your chemical formula. But what it actually looks like is this. You have a magnesium that lost 2 electrons. 2 electrons. So it's a 2+. You have one chlorine that had 7 electrons. We added 1, so that gives it a -1, and you did the same to the other one. This is actually what is occurring, and this is your formula. Let's try another one. Okay, let's try with sodium and oxygen. We're going to write down our sodium first because that is our metal. Sodium, when you look on the periodic table, has 1 valence electron. Oxygen is your nonmetal, and it has 6 valence electrons. Okay, so what we're going to do the same as we did all the other problems. Our metal is going to donate an electron to sodium. Sodium's got a spot right there, so it's going to donate one there. But now we're out of electrons to donate for sodium. So we're just going to add another sodium because we still need another electron. We still need another electron. So now this sodium is going to donate it right there. And when you do that, you end up with a sodium with a plus charge because we lost 1 electron. And another sodium with a plus charge because we lost 1 electron. Then we also have an oxygen that had 6 original electrons, and now it's got the donated electrons from sodium. So that's a -2 charge. So if you look here, this is a +2. If you look here, this is a -2. Overall, it is a neutral compound. If you were to write its formula, you have an Na, there's 2 of them, Na2, and 1 oxygen. That is our chemical formula. We're going to do 2 more practice problems. So let's do aluminum and sulfur. Aluminum and sulfur. So aluminum, if you look on the periodic table, that is your metal. It has 3 valence electrons. Sulfur, if you look on the periodic table, has 6 valence electrons. Okay, so sulfur needs 2 electrons. Well, along comes aluminum and says, I've got some electrons to give you. So he throws one in that spot, and he throws one in this spot. Now sulfur is full. Sulfur doesn't need any more electrons from aluminum. But aluminum still has 1 electron it needs to get rid of. So what do? Well, sulfur goes and gets one of his sulfur buddies and says, you know what? Aluminum's giving away electrons. Come get them while you can. So that's what sulfur does. Another sulfur shows up, and aluminum says, oh, cool. Let me get rid of this electron and give it to you, sulfur. So now aluminum is full. Aluminum has lost all its valence electrons, but sulfur still has room for 1. So what do? We add another aluminum. Aluminum can throw an electron there. Oh, but now sulfur's full, but we still have two electrons for aluminum. So what do? We add another sulfur with its 6 valence electrons. So this electron can go right here, and this one can go right there. And now we're full. So what does that end up looking like? Well, you have 1 aluminum that lost 1, 2, 3 electrons, so it's a +3. We have another aluminum that lost 3 electrons, making it a +3. That takes care of that. Now let's look at our sulfurs. We have 1, 2, 3 sulfurs. But how many electrons did we have? Well, this one originally had 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oops. 6. Okay? But it got, this sulfur here received an electron up here from aluminum and one here. This one received one here and one here. This one received one here and one here. Here it received 2 electrons. That's a -2. That's a -2. That's a -2. So what we have on this side is a +6. What we have on this side is 2 + 2 + 2. It's a -6. Overall neutral. So if you were to write its formula, it would look like this. 2 aluminums, 3 sulfurs. 2 aluminums, 3 sulfurs. Okay, we're going to try one last one. Our last one is going to be something like calcium with nitrogen. Okay, calcium is your metal, so it goes first, and it has 2 valence electrons. You can look that up on your periodic table. Nitrogen is your nonmetal, and it has 5 valence electrons. So we're going to do the same thing. Calcium is going to give an electron there and an electron there. But we still have a little spot available down here. So let's add another calcium. This calcium can give one of its electrons right there. But it still has 1. So what do? We add another nitrogen. So you can go right there. But we still have 2 spots for electrons. So we'll add another calcium. And that one can add one here. And this one can add one here. So what does this look like? Well, we have 3 calciums. One, 2, 3. This one lost 2 electrons. This one lost 2 electrons. This one lost 2 electrons. Okay? We also have 2 nitrogens, and they've each started with 5 valence electrons. Oops. 5 valence electrons. This one received an electron up here, an electron here, and an electron there. Now it's got 8 total, 3 of which were added, so we have a -3. This one also received 3, so we got a -3. So let's check our charges. +6, 2 + 2 + 2 is 6. 3 + 3 is -6. That's neutral. So overall, you have a Ca. How many Cas do we have? 3 of them. How many nitrogens do we have? 2 of them. Okay, the last thing we want to talk about is what's called our empirical formula. This is only true for ionic compounds. The chemical formula for an ionic compound, so a compound that has those charged ions, the cation and the anion, the chemical formula is arranged in the smallest whole number ratio, and that's called your empirical formula or your formula unit. Okay, so what that means is, let's say you do that throwing of the electrons, and for some reason you end up with a formula of Mg6N4. Mg6N4. You would have to find the lowest common denominator between these two numbers, and that number is 2. You can divide each of these numbers by 2 and get a whole number. So if you divide Mg6 by 2, you get an Mg3. if you divide an N4 by 2, you get an N2. So this should reduce to Mg3N2. Four ionic compounds, you must put it in the smallest whole number ratio. Okay, and to wrap up your ionic compounds, this is what's actually happening. You have sodium with 1 valence electron. You have chlorine with its 7 valence electrons. Sodium chloride is your table salt. What happens is sodium throws its electron or transfers its electron to chlorine. And when it does that, it goes from a neutral atom to a positively charged atom. It goes from a neutral atom to a positively charged atom. This electron now belongs to chlorine. So when chlorine receives that electron that has been transferred to it, it goes from a neutral chlorine atom. It gets an electron, now it's got a negative charge. So now you've got a positive charge next to a negative charge. And when that happens, you have this electrostatic attraction that sticks the two atoms together to make a very strong bond called an ionic bond. The next video will be over covalent bonding.